Hello and welcome to our presentation on the research field Systems Engineering in Smart Cities within the Research Center Dependable System of Systems Engineering at the University of Applied Sciences, Salzburg. We working on that is my colleague Goran Lastro and me, Regina Plesken. I have a strong background in the field of civil engineering, where I come from, but also did quite a bit of work within the field of digitization in construction and also geotechnical engineering. Goran, what about you?
Hello, my name is Goran Lastro and I'm a researcher at the University of Applied Sciences in Salzburg for the last 6 years now. I have a strong background in software and systems engineering, and together with Regina, I will be examining systematic approaches for the development and documentation of systems in the context of smart cities.
In the first part of our presentation, I want to show you our challenge and vision. Our challenge comes from the field of smart cities. A smart city meaning ICT and connected devices optimize efficiency of city operations and services and connect to citizens. Within that, some technical challenges arise. First of all, the dependability, meaning that smart cities involve quite a bit of critical infrastructure for living. Second of all, a smart city is a system of systems, meaning that several subsystems working together to be the bigger picture. From that, there can things arise like emergent behavior. And third, we have to look at the stakeholders, because there are various domains and disciplines involved, so also the human beings play quite a bit of a role. From that, the remaining question is how to enable the development of dependable smart cities in this context. We have a quite good point to start from. The IEC already did a bit of work on smart city reference architecture methodology, the Scrum, and a smart city architectural model, SCRA. But these two are so far only document-based and on a rather high abstraction level. Further on, some limiting factors play understandability, the applicability, and the usability. And last but not least, the concern. So the stakeholder acceptance is also quite important to work on. All that leads to the smart city modeling toolbox, which we want to set up. This toolbox will contain all the knowledge coming from Scrum and Scra, taking the methodology and also viewpoints from them, combining it with existing notations. That gives us the possibility to be interconnected to other modeling toolboxes and also connect the smart city to further domains. And third, we want to integrate existing tools and domain knowledge, where my part comes in as civil engineer. All that together builds the smart city modeling toolbox, which should then be interconnected to the smart city model. The smart city modeling toolbox is object modeling of smart city architectures. It should be there as add-in for commercial modeling tools and in a language as DSL based on the Scrum viewpoints. It should also contain further automation capabilities. And which is good, our colleagues at the chair already worked on similar things like the SCAM toolbox and the RAMI toolbox. So we can gain from their experience and take that knowledge into our smart city modeling toolbox further on. In part 2, we want to show you the concept and approach of the smart city modeling toolbox. Started from a project concept, we are now in the phase of feasibility study and proof of concept, and looking forward to the toolbox implementation in some steps. Within our feasibility study, we do research for relevant standards and notations. We select a study use case from the smart city domain and initiate specifications of DSL for the selected use case, meaning the abstract syntax model, the concrete syntax model, and the semantic model. From there, we also integrate selected Scrum viewpoints and relevant notations for that. Following is the proof of concept. Within the proof of concept, we implement with the Smart City Modeling Toolbox this chosen use case and tailor from there on further selected use cases. So go on.
Our starting point is finding the right means for the description and development of architecture for systems in the smart city context. Whereas in building architecture, the tools and diagrams used are known to a broader audience, the picture in the smart city context is not that clear. That's where the ISO 4210 standard comes into play. It defines that every system of interest needs an architectural description which addresses all its stakeholders and their concerns and is also governed by defined architectural viewpoints and model kinds. Only then the description can address all important aspects and provide the necessary information. In general, stakeholders are persons, groups, or organizations with an interest or influence in future solutions. In the smart city context, they are created on basis of IEC generic system rules and are elaborated together with their concerns as part of the IEC Systems Committee on Smart Cities. A viewpoint frames the concerns of a stakeholder and governs the creation of particular views. In other words, it answers the question, what does a stakeholder want to see to address their concerns? The Smart City Reference Architecture methodology defines several viewpoints which together frame a holistic perspective on smart cities. Here, only a selected choice of the Scrum viewpoints are shown. According to ISO 4210, every viewpoint is associated with various model kinds, which provide conventions for modeling and creation of concrete architectural views. For example, the implementation viewpoint consists of 4 different model kinds: platform-based implementation, sources and builds, integration, and deployment topology to describe all necessary aspects. This brings us to the Smart City Toolbox, which we are creating alongside our efforts. Therefore, we utilize the Agile Design Science research methodology, where in the first step a case study needs to be selected. In our case, it's a simplified smart city scenario. In the next step, the requirements are derived using methods of requirements engineering, which prepares us for the third step, the development of the process model and modeling paradigm, alongside with the domain-specific language and the tool implementation which is necessary to apply this case study and create a model out of this. The learnings and experience from the creation are then taken back to the case study, which is then adapted and ready for the next step of this method. Right now, we are working on 2 case studies. The one, charging infrastructure, which focuses on technology and is a bottom-up approach. Its goal is to identify required technology, standards, and stakeholders for an individual e-car charging solution. The other is about city mobility. It is a top-down approach which describes mobility as system of systems, investigates interactions between those systems, and derives a strategy for overall mobility concept. The implementation goal is a domain-specific language and a toolbox with additional functionality for the developers. The domain-specific language itself is a SysML profile which covers various viewpoints, model kinds, and model elements, alongside the semantics and correspondence rules for creation of models in the smart city domain. The toolbox itself will be delivered as an Enterprise Architect add-in and will consist of the DSL itself and additional functionality, for example, transformations, templates, and various other features which will help developers create the models for their systems. This provides us all necessary means for the architectural description in the smart city context. To aid architectural development further, a reference architecture needs to be created to serve as a blueprint for smart cities and a type for individual instantiations, which can be provided as a model to individual developers to help them create their system descriptions. As a conclusion, it can be said that while the valuable efforts of the IEC System Committee on Smart Cities is focusing on documents, our research efforts are shifting document-centric approaches to more model-centric approaches, while we also deliver value for standardization bodies and their customers. If you want to learn more on our research, visit us at en-trust.at. Thank you for your attention.